Hey guys, welcome back. And today you are going to be taking some notes in your interactive science notebook, your ISN, on kinetic energy and potential energy. So please go ahead and open up to your next page in your ISN and title the top of the page, Energy, Kinetic, and Potential. If you need a moment to get that done, you can hit pause now or at any point in the video to slow down and copy down the notes that you need. Let's get started. So, what exactly is energy? Energy is the ability to do work or cause change. Now notice ability is in italics here. And that's because just because you can do work does not mean that you are doing work. So just having the ability to do work, whether you're doing it or not, means that you have energy. Now, energy, like all things in physics, is measured in a special unit. This unit is called joules, Joules, and the abbreviation for joules is a capital J. So anytime that we are talking about energy, you need to be thinking joules. Or when you see the capital J after a number, you should understand that that means joules. Feel free again to pause it right here if you need to finish copying these notes or move on. So we talked about energy being the ability to do work, but what exactly is work? You know what schoolwork is, you know what going to a job is, but what is the physical definition of work? Work is exerting a force on an object, causing it to move. So that means energy could cause objects to move, or it could not cause objects to move. So anytime you're applying a force is going to be a push or a pull on an object. So it could be like you pulling a chair up to put it up on the table, pulling against gravity, or gravity pulling an object back down to the ground. So work actually has an equation, and it's when you apply a force, so that's push or pull, and the object then moves a certain distance, so it changes its position. So when you do work, or you could do work, you could apply a force, and it would move at a certain amount of distance. And that is what energy is. Now, because doing work is energy, it is actually measured in the same units as being joules. Now there are two types of energies, kinetic energy and potential energy. So let's try an experiment. Take your pencil or an eraser or something and hold that straight out in front of you at eye level. What kind of energy does that have? Could it do work, or is it doing work right now? That's right, it could do work. So that has potential energy. It has the potential to move. I mean, you might be vibrating it a little bit, but it's pretty much staying right out there in front of your eye level unless you're moving your arm around. Stop moving your arm around. Now, let go of the eraser. You probably noticed that it fell. While the eraser was falling, or the pencil, it had kinetic energy because it was moving. Kinetic energy is the energy an object has because it is in motion. It could be the motion of particles vibrating, giving us thermal energy, or it could be big things moving around. And those things actually are doing work. A force is being applied to them, a net force is being applied to them, and it is causing it to move. Now there are two things that are going to affect how much it's moving. Number one, the speed that it's moving. And it's more than just speed, but velocity. And we'll talk later on about what the difference between speed and velocity is. It's a small difference, but it's important. And also how much matter that you're moving. That's the mass. And so if we're comparing two different things that we can measure speed. We can also measure an object's mass. We're going to have a formula. So the formula for kinetic energy, which we abbreviate as KE, is the mass of the object times the speed that it is going, or the velocity that it is going, squared, and you divide the whole thing by 2. So if you take a look at this formula, what has a bigger impact on kinetic energy? Mass or velocity? If you answered velocity, you'd be correct because the velocity here is being squared. So it has more impact on the total kinetic energy. So let's take a look at an example. We have the red car and the green car, which have about the same mass as one another. But notice that the red car is moving at 100 kilometers per hour. Since it's moving faster than the green car, it has more kinetic energy. It requires more energy to make a car move fast than it requires to make the car move slow. Now, if we were to compare the green car to the motorcycle, notice that their speeds are the same. So which of these has more kinetic energy? If you answered the green car, you'd be correct. The green car has more mass that it moves. That's why a motorcycle uses less energy. And a lot of people who are concerned about energy, gas and stuff that is being used for their cars, they pick smaller, lighter vehicles, or if the weather is even nice, they might pick a motorcycle to drive because it uses less gas. Now, the other type of energy is the potential energy, and that's when you're not doing work, but because of its position, it could be doing work. Now, you can have elastic potential energy, which is the energy associated with an object being stretched out like an elastic band or compressed and squished together like a spring. And if you release the pressure on that, the rubber band or the spring would move. So it has the potential to move, but while you have it squished or stretched, it's not moving. On the other hand, we have gravitational potential energy. Gravitational potential energy is like when you were holding the eraser at your eye level. It had the potential to move because of its height, but it wasn't moving until you dropped it. The amount of energy that the object has because it could fall is gravitational potential energy. And it's going to depend on a couple things. It's going to depend on the mass of the object, and it's going to depend on the height that the object is at. Now, if we look here at the formula, we have 2 different formulas. This one right here shows W times H. W is referring to an object's weight, which is the amount of gravity acting on the mass. So if we look at this formula down here, mass times gravity times height. So if we have the mass of the object, and on Earth, the gravity is pretty constant, so we generally just refer to it as weight. But if we were on a different planet, we would have different potential energies because of the force of gravity. On Earth, the force of gravity is going to be 9.8 meters per second squared. So I'll write that here for you guys. So it's 9.8 meters per second squared. And the fact that I took the time to write that out, and that's the gravity here on Earth, means that you should probably write that number down in your notebook. It's an important number. So mass times gravity is an object's weight. So you can write it in 2 different forms. So if you have an object's mass, the unit for mass is going to be a kilogram. And the unit for weight in the SI system, which remember is the international system, is a special unit called a Newton, which we symbolize with a capital N. And it's named after Sir Isaac Newton, who had the laws of motion that describes forces acting on objects. So weight is measured in newtons. So if you see a capital N, you're going to use the weight times the height. And if you see kilogram and you know that it's on Earth, you're going to do mass times 9.8 times the height. So what this means is that if an object is heavier, has more mass, and you're going to drop it, it's going to have more potential energy. Or if you drop it from a higher height, it's going to have more potential energy. So let's just check in real quick. So this can go on the right-hand side of your notes. Okay, so what is the unit that energy is measured in? So energy is measured in joules, and it exists as kinetic energy and potential energy. Okay, and potential energy can either be elastic or gravitational. And energy itself is the ability to do work. Now, in the rest of your page, what I would like you to do is draw an example of kinetic energy and potential energy. You can either do two different examples or you can do one drawing that combines the two. Thanks for watching.